So this is a hard problem, and it's really a counting problem where we need to figure out the number of ways I can create these relationships by connecting them. Now, if we first try to find out how many different ways I can create the functions without any constraint, then we can see that 2 could be paired this way, 3. So we have for each one of these elements in A, I can connect to 3 of these. So I have 3 choices here, 3 here, and I have 6 of them. So the total number of possible ways would be 3 multiplied 6 times, or 3 to the 6, or which turns out to be 729. Now, I have to satisfy this condition that at least one element in A such that our range is included. So that means that I need to have each one of these 1, 8, and 27 somehow be mapped to one of these elements in A. Because this will include cases where that's not the case. For example, it could be where we're just looking, this number will have something where these inputs only match to 1 and 8. So we have to subtract those. So the next step is counting in ways where not all of these are here. So for example, B, let's say, has only 1 and 8. And A has 2, 3, 5, 7, 11, 13. So I'm going to count how many ways I could pair these, and then I'm going to subtract that from here. So here again, I can pair that to 2 of these. So I have 2 choices each step. So this will be 2 to the power of 6, which is 64. Now also note that this will also include the case where all these numbers are only paired with 1. And all these numbers are paired with 8. So I have to subtract those 2 cases. That means there will be 62 where exactly both 1 and 8 will be mapped to these 6 elements. And we have 3 such cases because we have a total of 3, 1, 8, and 27. So this is 1, 8, 127 will be another case, and 8 and 27. So we'll get 3 such scenarios. So the total would be 186. So 186 is the number of ways where not all elements in B are being mapped to A. And that's what I'm doing, is subtracting that from that total. Now, of course, we also have the case where all of these elements are mapped to only one of these. And that's going to be 3, because you can map all 6 to 1, or all 6 to 8, all 6 to 27. So I have to subtract that as well. So this is the complementary approach where we're figuring out what we're interested in by first counting the all possible ways we could do something, and then subtracting the cases that we don't need because of that constraint. So we just have to do this computation, and if you do this subtraction, you'll get 540, which is choice B.